So in this video, we're going to talk about markers and the various ways that you can use them. Markers are extremely important when you're scanning if you want to keep tracking and collect high-resolution data. So we're going to go through all the different methods you can use them to your advantage. All our scanners come with a pack of markers like this. Normally, you can take these markers and stick them onto a part like this. You'll want to keep them around 1 inch apart with around a 10 inch by 10 inch area. And you'll want to place more on the edges of your part if you're looking to combine the first half, the front half, with the second half or bottom half. Now, these markers can be kind of hard to remove when you place them on the object. So one tip we have for you for that is you can purchase blue tack and take some of the blue tack, roll them into little balls, and then put the markers on them, like so. And if you stick these onto the part like this, you'll see that they're much easier to remove and to reuse than the regular markers. Another way to use the markers is with plastic sheets like this, translucent plastic sheets. And this is really helpful for keeping tracking over a wide flat area. So for example, if you're scanning a car door and you didn't want to put markers all over the door, you can stick the markers on sheets like this, place this onto the car door, and you can start scanning the data underneath the sheets while the markers on top keep tracking. And then you'll be able to take these off and reuse them for another project. Now, the object that we're going to be scanning today is this valve cover, which I've marked up on the front side and also on the other side. And we're first going to do a rapid scan so that we can just get the overall shape of this object and also get the positioning of the markers for this entire thing. And then we'll be able to export a marker skeleton or a global marker file, which we can import into our fixed scan mode and then start scanning. And we'll be able to collect much higher resolution data in this mode. And the data will automatically align itself to the marker skeleton that we've made in the handheld rapid scan mode. So this is a really useful way of using the rapid scan mode to first get an overall shape of the data and the marker positions, and then going into the fixed scan mode to get high quality data really quickly. So now let's go into the scan. So for this valve cover, we're going to use the handheld rapid scan to create a marker skeleton or global marker file in a medium resolution scan, and then we're going to use that global marker file in the fixed scan mode so that we can get the best resolution possible on this part. So let's go ahead and start the rapid scan. First, we need to create a folder to hold the scan data in. I'll name mine valve cover. We're going to do a non-texture scan with marker alignment, operation mode classic, and in medium resolution. The resolution we decide for the scan won't really matter because we're not really going to use it, but a medium resolution scan would give you pretty clear features. I'll hit apply and open up the scan preview page. Opening up the left camera here. So during the scan, we can focus on the markers and just get the overall skeleton of markers that are on this cover. And we're going to use that in our fixed scan mode. I'm scanning the cover while it's upright so that I can see both sides. I also placed a sheet of markers on the bottom to help me keep track near the bottom of the cover and the floor. Our goal is to get as many marker positions as we can for the P3 file. So I'm going to preview the scan first by finding a place where there's a lot of markers and then click again to begin the scan to start collecting all those marker positions. I'll be adjusting the brightness during this, such as turning down the brightness when I see many red lines in the camera view, and painting in the cover from different angles. The good thing about having the marker sheets on the bottom is that when I want to scan to the other side, I can just focus on the markers on the sheets, which will bring me to the opposite side. One round of scanning, front and back, should have already captured a lot of markers that I can use in the next scan mode. Also, if I lose tracking during this, I can place the focus on the marker sheet where there's a ton of markers for the tracking algorithm, and then I can start again to finish the rest of the cover. We don't need all the markers because when we do the next scan, we may capture all the remaining missing markers. By having a good skeleton, we are making it easier to fill in this model in the fixed scan mode. I also want to scan this while it's on its side, and I'm going to put it on top of black cloth so the backgrounds won't appear. You can use some of the selection tools listed on the bottom here. Shift left mouse to select and delete this data here or here. Middle mouse to pan, hold left to rotate. The markers on the floor work for a lot of scenarios. If you are capturing the faux skeleton of your model. Now I can scan both sides individually, even after repositioning the cover face down. The left camera view will show you the difference in exposure between the cover and the cloth and why you can't capture it. My goal for placing this face down is to try and scan a couple more markers. I'm also going to turn it around so I can get some more markers on the other side. And with this, I think we have all the markers we'll need to complete the scan in higher resolution. We'll go here to generate the point clouds first, and then we can save out the P3 file. The data here is saved automatically in the project folder we created in the beginning. At this point, we can just save out the point cloud file ASC or the global marker file P3. I would recommend saving this in the same project folder as the rest of the data. Click confirm, hit this button, and we can move on to the fixed scan using the global marker setup. Create a folder which we can hold the data. Opening up the global marker file when you get to this point. Hit apply and you should see the markers appear. Each shot that we take with these markers in view will align the data to the skeleton. In order to use the fixed mode setup, make sure that you have the scanner on a tripod. We won't need the turntable here because we'll be focusing on the markers. You want to position the object so that the projector cross is close to this red cross that you see on the screen, and that will tell you that the object is in focus. Once it's close, hit the scan button. The scanner will take a single shot and give you the data and the marker positions. When you hit apply, this will align to the marker skeleton. One shot generated 700,000 points in a small area, so this is a really dense point cloud. We're going to keep taking single shots and move the object to change the focus. Make sure the brightness setting yields a focus with a good exposure. A couple of areas, but not all over typically, that's red, has the best results. This valve cover is medium gray titanium, so I think this would be a good exposure. A larger scan frame would also make this much easier, quicker, as it can take in more area. The Einscan Pro 2X has a scan frame of around 10 by 8 inches. The Einscan Pro HD has a scan frame of 12 by 10.5 inches. The Einscan HX has a scan frame of 15 by 16 inches. Each single shot that I take is giving me a lot of markers to merge to the skeleton, and that's why it's going so well. There were some markers that we couldn't get before from the handheld Rabbit scan, but I think that extra scan of the front and the back helped capture a good skeleton for us to fill in. Now we have the front surface, and we can go on to the opposite side. Let's turn up the brightness a little bit and move closer. We are going to continue the scan by repositioning the object and the scanner when necessary. And that's it. We have a valve cover scanned in medium resolution and one in high resolution. We're going to save these out for later. I also wanted to scan one of the parts that I showed you earlier, so that you have a good idea of how to align the top half of the scan with the bottom half scan. And we're going to be using the fixed scan mode for this. So let's go and create a new folder to hold our data. And then select either texture scan or non-texture scan. For this, since I don't have the color camera, I'll go with non-texture. And here's the object that I showed you earlier. You can see I have a lot of markers on it. And it's also a little bit overexposed, so I'll bring down the brightness so that there's just a few red lines. And you can see that in this first scan, the camera is going to pick up all these markers in red. And that's really good because we want to have as many markers as we can in the first shot that we take, so that when we're rotating the objects, that there are markers that it has already scanned and it can align the data to those areas. So I'll show you what I mean. This is without the turntable, so you can use the fixed scan mode without the turntable as long as you have markers on the objects to help with the alignment. And you can see that in the first shot, I got most of the data in this area, a lot of the markers, and I also got some of the table, which I'll delete from the scan. And I'll also place this on a black cloth so that I won't scan the table anymore. Once I have the top half finished, we can move on to the second half. In order to align these two halves together, I placed a lot of markers on the edges here because this area will also be scanned when I flip it over. We'll be able to combine the two halves because there are these around 3 to 4 of these markers on the edges to complete the alignment. If we go over to the left here, we can see that there's project 1, which we can toggle on and off. We can also create a new project that holds the project number 2, which will hold the bottom surface. Let's try to get as many markers as we can in this first shot. So it looks like we got 2 here on the edges. Let's continue to fill in the missing area. Some areas can be hard to capture because shadows will cover it at many different angles. We'll just have to try our best at finding the right angle and rely on the hole filling method afterward to fill in any holes. Now let's see if we have enough markers on the edges to do our alignments. We have all 4 on the edges, so I think we're good. We should have enough data for the full model as well, so we're ready to align the data. We have 2 projects that are floating in space, so let's go to the Align tool here on the right. We'll drag the first project to fixed and drag the second project to floating. Reposition the cover with the pan and rotate so that both views, fixed and floating, are similar. Select the 3 markers on the edge. So these 2 here will correspond with these 2. And we'll pick the last one, which is over here in the front. And we did it! We've created a complete model. We can click Next and then Complete, and you can see now that those 2 scans have merged together where the markers are. We can also continue the scan at this point. If I hit the scan button now to start, it will collect more data, and as long as there are 3 or 4 similar markers here to the scan, it will align to it. or at least it will align to the project 2 folder we created here. Next, we can create the mesh model and export the STL. In the next video, we're going to talk about how we can use marker sheets to scan large flat surfaces, for example, on a car door or on another flat surface like the floor or the wall. So I'll see you guys in that next video. Thanks for watching.